Hello and welcome to this video in the R Analytics course. In the previous video, we saw how to conduct a t-test on a single variable. We conducted a t-test to see if the mean of the population which was claimed was true or not. In this video, we will conduct a t-test on two sets of data. We have a credit card company with teams in Delhi and Mumbai. The strengths and the catchment area for both the teams are equal. The remuneration levels are also very similar for both the teams. The company now wants to see if there is a significant difference between the average sales of both the teams. We assume that both the samples from Delhi and Mumbai are completely independent of one another. The test conducted is to see if the means of both these teams are same or not, and it is called a two-sample t-test. It is also known as the difference of means test. If the difference between the two teams is concluded to be zero, it will imply that the means for both the teams are the same. Here is the data that we will conduct a test on. There are 25 observations each. We will now import this file in R. We will use the R Commander package to import the Excel file in R, which has the graphical user interface in it, which is also known as the GUI. To install the package, we write install.packages and in brackets we write rmcdr, where R must be in capital. The moment we press enter, this package will be installed in R. We must ensure that the internet is connected at this time. Since we have it installed here already, we will use this package by writing library and rmcdr in brackets. As we press enter, we can see a new window has opened up in front of us. This is the R Commander window. In R Commander, we can write as many statements in one line or one statement in multiple lines. To run a command, we have to press Ctrl+R. To import a file, we have to go to the Data tab and then import the type of file we want to. We can also use various packages in it. In the Summaries tab, we can find the summary of the data, mean, variance, conduct tests, cluster analysis, and also fit models to a given set of data. As mentioned earlier, we can plot various types of graphs through this package as well. Let us import our data first. Once we click on the Excel file, we get a dialog box which asks us to name the file we want to import over here. Say we name it as TS. The first option says that the first row of the data will be treated as headers. The second option is unticked so that the first column is not considered as headers. This option is used when the data is transposed and the first column has the headers instead of the first row. Lastly, R converts character into factors. By default, all the missing data will be indicated by empty cells. As we press OK, we then browse to the file we want to open. Then we have to mention the sheets we want to import from the Excel file. We select sheet 1 over here. As we press enter, we can see that a file named TS is created. The moment we write TS and press Ctrl+R, we see we get the whole data set at the bottom. Since the file has been imported in R, we can check this in R console also by typing TS and executing the command. To conduct the t-test, we write t.test. The first argument is the first set of data or the sample, which is $Delhi. The second argument is the second sample, which is $Mumbai. If we close the brackets here, the rest of the arguments will be set by default. So by default, R will take it to be a two-tailed test, variances of the two samples to be unequal, etc. To see the whole syntax for the t-test, we can also write help t.test. As we press enter, we get the whole syntax for this in R. The first two arguments are x and y, denoting the two samples. Alternative is that it will be a two-tailed test, followed by mu is equal to 0. That is, the null hypothesis is that the population means are equal to each other. Then we have paired data equal to false. Var is equal to false implies that the variance of the samples are unequal. And lastly, the confidence limit is 95%. We need all these settings for the test we want to conduct. Hence, just by giving the two samples only, we can press enter and conduct the test. So we write t.test and give the two samples of Delhi and Mumbai. We press enter after that and get the output. The calculated t statistic comes out to be 3.3195. The degrees of freedom is n1 plus n2 minus 2, which is 48, and the p-value is 0.1728%, which is less than 5%, which implies that we reject the null hypothesis. Hence, we can safely conclude that the means of the two samples of Delhi and Mumbai are not the same. We can see that the calculated value for t statistic is also very big. Hence, it will lie in the rejection area. The null hypothesis, as mentioned earlier, was that the means are equal for both the cities. The confidence interval ranges from 3.8797 to 15.8002, which does not have 0 in it, indicating that there is a difference between the means of the two cities. Also, since the interval is positive, it means that the mean of the first sample, which is Delhi, is greater than that of Mumbai. This is how we conduct a t-test for difference of means or on two sets of data. Now we will look at paired t-test. Paired t-test is conducted on the same sample but at different times. For example, we have the data on sales of the Delhi team before and after the sales training, and we compare the performance of the team by analyzing the means of the team before and after the training, that is, at different times. Basically, this test would help us conclude whether the training was effective enough to change the sales significantly or not. These tests are used in the medical domain considerably to check for the effects of medicine and their significance. To remove the data from here, we can go to the Edit tab and click on Clear Window. We have an Excel file with the data for the fitness center, which wants to test for the impact of a protein shake on its members. The figures here show the number of rounds of a particular workout regime its members did before and after the shake. So the figures after taking the shake have to be tested against the figures before taking the shake to see if the stamina of the members have increased or not, and if they are able to do more rounds of workouts or not. This kind of a test concludes the effect of a particular thing before and after on the same sample, and hence is known as the paired t-test. Firstly, we go to R commander and import this file in R. We name the file as ptt. Rest of the options remain as it is. To check for the data, we write ptt and press Ctrl plus R. In the console window, we press Ctrl plus L to clear all the things, and then we write ptt and press enter. We write t.test and give the arguments for before and after, and then mention paired equal to true. As we press enter, we get the result for the paired t-test. The t-statistic comes out to be minus 0.082488. The degrees of freedom will be n-1, which is 20. P-value comes out to be 41.92%, which is greater than 5%, which means we cannot reject the null hypothesis. The null hypothesis by default is that there is no significant difference between the means of the two samples from before and after, which implies that the shake is not effective. However, since we cannot reject the null hypothesis in our case, it is concluded that the shake had no significant impact on the stamina of the members. We can see that the calculated t-statistic is also very small, which means it lies in the acceptance region. The confidence interval 2 ranges from minus 8.23 to 3.57, which has 0 within it. Thus, not rejecting the null hypothesis is the correct conclusion. This is how a paired t-test is conducted in R. This is it for this video. Thank you.